Today I am going to talk about special casting methods. We have already discussed about sand casting. Sand casting where we use a molding sand as a molding material. Okay, so basically sand casting is done by hand, so it's a manual one, and we have seen that almost all types of casting is done by sand casting, but still some special kind of uh, products which are to be made. So we it has been observed that some other types of casting methods are more economical and more fast than the sand casting, and that's why these castings have been developed. So we will talk or we will discuss today about those casting methods. So what are the different casting methods we will see here. So if we categorize all the casting methods in separate categories, then we can divide in this way. Uh, First, we will talk about like cell mold casting, and slush casting. So both are put under one head, slush casting. Then there is a permanent mold casting or die casting. This is another head, die casting, where a permanent mold is used. So here permanent mold, that is one. Second one in this is die casting. This die casting is of two types: hot chamber die casting and cold chamber die casting. Third one is vacuum. This is pressure die casting. So this there will be vacuum die casting. Then there is a low pressure die casting. Actually, this has been developed because of some kind of inconveniences in the earlier methods. Like there were some kind of demerits in the permanent mold casting, which is also known as gravity die casting. So these are all coming under the head die casting. Then next we will talk about centrifugal casting. Under this there are three methods. One is true centrifugal, then semi centrifugal, and then centrifuging casting. And the last one we will talk about continuous casting, and there is another one, that is squeeze casting. Okay, so these are the four different categories: one, two, three, and four. So cell mold casting and slush casting. Why I have put them together? Because both are almost uh, there is a confusion, like generally people get confused among cell mold casting and slush casting, although both are very different. And that's why I put in one category, because if they are in one category we can easily differentiate among them. And continuous casting and squeeze casting, basically these are casting and forging mixed. So we will talk about this one by one. So let us start with the cell mold casting. So cell mold casting, what is done actually? So here the pattern, a metallic pattern is used. We require pattern, isn't it? We require pattern. So we require, so here heated metallic pattern is used. Okay, metallic pattern. Now pattern, after that we want mold material or molding material, isn't it? So what is that molding material? So it is sand mixed with a thermosetting resin. So there will be sand plus resin, and that is thermosetting resin. Okay. So this is dry sand actually. So how there will be binding? So this is the binding agent. So this resin actually, when it is heated, because of the when this resin comes in contact with this pattern, then it gets heated and it mixes with the dry sand, and after that it gets solidified. Okay, and then the cavity is formed. So let's suppose if we want to this is a plate, metallic plate. Okay, and we want this kind of cavity itself. So this is a metallic plate like this. Okay, now what is done, that this is heated, this metallic plate is heated, its temperature is raised up to 150 degrees Celsius, around that. And after that on this plate, the dry sand and resin mixture is put over here. Okay, what will happen due to that? The resin that will melt and mix with the dry sand, and after that it gets solidified because it is a thermosetting plastic. Thermosetting plastic. So once melted and solidified, it cannot be again remelted. Clear? So this is like after solidification, it becomes very hard. After that, this pattern has to be removed. This pattern will be removed. So we will get a hardened this kind of mold. Clear? So now you can pour molten metal in this cavity. Clear? This pattern will be removed after that. So this is what is cell mold casting. So actually here what is the cell and mold? So the mold is in the form of shell. What's the meaning of shell? Shell means there is a the thickness of the mold. You can see the thickness of the mold is how much? This is the mold. So the thickness is very less. Clear? This is the pattern. This is pattern and this is mold. And the thickness of mold is very less. So it's in that we say shell. Clear? So now this thickness depends on various factors. There are two factors. One is the temperature of this plate, that is pattern, and the time by which this like sand will be put over the surface of the plate. So as much time it is like put over here, that much thickness you will be getting, because that much resin will be melted. And also it depends on the temperature. If the temperature is more, then the thickness you will be getting is more. So let us proceed further. Okay, so which resin is used? So phenol formaldehyde resin is used, which gives you higher strength and resistance to heat. So this is a thermosetting plastic. Okay, so curing time, I told that on the temperature and time it depends. So on temperature, that means the temperature generally which is used is 150 degrees Celsius, and the time like by which that sand is put over the plate is 50 to 60 degrees Celsius. So you can see here is the diagram. So you see this is the pattern. Okay, so this pattern is heated, and after heating Now you can see this is the sand with the resin, and this whole box is rotated. So when it is rotated, the sand will fall over the surface of the heated pattern, and due to that a layer is formed. Are you getting? And this is cell. This is the cell mold. Okay, so it will be having that much strength by which it can sustain the molten metal. When you will pour the molten metal in this cavity, then this much thickness itself is going to sustain the molten metal. Okay, so this all we have already discussed, and this actual thickness required, how much, that is completely based on heat and trial method. You cannot um, there is no mathematical formulation of this one. Okay, so this all has been covered already in the previous classes. Advantages, yes, there are various advantages because of which this one is used. We get more accurate dimensions, a smoother surface. This is very important. These two are very, very important, that we get, first of all, accuracy is good, and the surface we get is a smooth, so roughness will be very, very less. Okay, this is used for this purpose. Very thin sections can be easily made by cell mold casting. Okay, permeability of the cell is very, very high, so no gas inclusion, there is no defect of the gas inclusion occurs. Okay, here a very small amount of sand is used because the thickness of the mold is very, very less. Okay, and mechanization is possible because of the simple processing involved. Next, there are certain limitations of this, that is like, it is not economical if you are going for a very small scale production. Okay, if you are going for very smaller scale production, then sand casting is better. So why to go for this one? So until and unless you don't have large scale production, like above 15,000 or 20,000 pieces which is to be made, then better not to go for this one, because it will be costly, it will not be economical. Okay, second is highly complicated shapes cannot be obtained, and maximum weight 200 kgs only can be casted. We cannot go for more because of the handling problem, and obviously because the pattern is very, very hot at 150 degrees Celsius or 200 degrees Celsius, so obviously we require sophisticated equipments to handle that heated metal pattern. Clear? So let us move further. There are applications. So see, the cylinder and cylinder head of IC engine is made by this cell mold casting. So very important, cylinder and cylinder heads of IC engine is made by cell mold casting. And there are other many other, like a small crankshafts are made by this. So next we will talk about precision investment casting. This is already covered, we have already covered in this. I'll just recap it, that precision investment casting, first of all, precision, very important. The term precision tells about everything. If we want any casting which is to be made very, very dimensionally accurate and precise, then for that purpose precision investment casting is used. And in this case, pattern is used molten wax. Pattern material is wax. So with the help of wax, you see, the cavity is made. Okay, so in previous one, that is cell mold casting, what was the pattern material? It was metal, on heated metal, isn't it, on which the molding material was. But here it is wax. So like this wax is molten wax is used, and it is put in the die, and after that it gets solidified. After that it is taken out, and many such small pieces are attached together, okay, through a runner. This is runner. So molten metal, if it is poured inside like this, then it will go to this one, this one, this one, this one, this one, and this one. In this way it will go, isn't it? So here it is done. Okay, now it is uh, dipped into a slurry. Okay, and this slurry is made by suspending fine ceramic materials. Okay, so ceramic materials are there. After that, uh, because the slurry is stuck over there on the surface of the wax pattern, so then dry refractory grains such as fused silica and zircon, so these are, like, it's a it gets we like do the coating through the dry refractory grains on this above. So first of all, there is a wax pattern. This is wax pattern. Above that we apply slurry, ceramic slurry. This ceramic is what? Which material it is? Sodium silicate or ethyl silicate. Okay, above that we use dry refractory grains on the top. Okay, so they get stuck together, and after that this wax is taken out, then we will get the cavity. So like that only. Now how you are going to take out the wax? So that is very important. The wax is taken out by heating this one. So if you increase the temperature, you just heat it, okay, then what will happen? The wax will melt and it will come out. Okay, so that is what molds are then preheated to a temperature of 100 to 1000 degrees Celsius. Up to 1000 degrees Celsius also it is heated. So due to that, the wax which is there inside, that gets melted or sometimes vaporized and comes out. Okay, so we are getting the cavity. Now in this case, as you are able to observe that we need not to take out the pattern from the mold which is created. So there is very less chance of distortion. There is very less chance of breakage of mold. So that's why we get very first of all, the speed of casting will be very fast, and the second one is the accuracy. The product which is made is having very precise dimensions. Okay, so this is all done. Next, we will go for permanent mold casting. Also is completed, we have already told. So okay, here from here this one starts die casting, isn't it? Die casting. But this is not die casting, this is known as gravity die casting. What is die? Die is actually, it's a, like we make mold cavity, isn't it? We make a cavity. Let's suppose this is a cavity. So how do we make? We use molding sands. This is sand. So by that we make the cavity. Clear? This is mold cavity. Mold cavity. And this is molding sand. But this is a temporary mold. Temporary mold. Why? Because after every casting we break this mold. But in case of permanent mold casting, the mold, the cavity and mold, it is not broken. So that is made up of basically metal. It is made up of metal. This is metal. Okay, and this is the cavity. So here this is permanent mold casting. And this permanent mold is also known as die. So understood what is die? So die is basically a permanent mold. Okay, so cavity is already made, so you can do thousands of castings with one cavity. But in case of sand mold casting, we have already seen that after every casting we have to break that mold. Clear? But here the point is gravity. That means the molten metal which is coming inside the cavity is under gravity. It's why it is coming down. So under the gravitational force only, there is no pressure applied over the molten metal tube. It is not forced inside the cavity. So when it is not forced, that means any only simpler cavities will be filled. If it is very complicated, like this kind of cavity, something like that, something very complicated cavities are there. So now you tell me, can the molten metal go there? Will molten metal like it will reach here? It is very less chance, because it is not forced. This molten metal is not forced out, there is no pressure applied. So it may happen that molten metal does not go to every corner of the cavity. So only simpler casting can be done, and that's why next we will talk about, that is pressure die casting. So last class we have already talked about permanent mold casting or gravity casting. We will talk today about pressure die casting. Okay, this is the die casting, or sorry, it's a pressure die casting. Yeah? So preparation of components by injecting molten metal at high pressure into a metallic die. So molten metal is injected inside the cavity, inside the die, at a very high pressure. Okay, so here we are using reusable metallic die. That means how much you can reuse. So you can even go for 10,000 castings also with one die. Clear? This is okay. So that is what reusable casting dies. Now this is also known as pressure die casting. I told you that die casting means, as soon as die casting you see, it is pressure die casting. As soon as you see permanent mold casting, permanent mold means it is gravity die casting. So because a pressure is applied, so any narrow sections, any complex shape, or any fine surface detail also can be easily produced. Okay, so that is the you can say the advantage of this die casting. So as we can see here, this is a plunger used, piston. So by this piston, force is applied on the molten metal. This black color is molten metal, and this goes inside this cavity and it fills that whole surface. So it may happen that if you are going for gravity die casting, then it may happen that this section is left without any material like this. Okay, so that's why by pressure die casting we can easily fill all the gaps. So you can see there are two half. One is, so obviously we know that in the mold, or there are two dies. One is upper die or lower die. We have already seen that in the sand casting, one is cope and drag. One is a drag. This is drag. This is cope. Similarly, here you will find there are two halves. One is moving half and one is a stationary half. Okay, and you see, because it is a permanent mold, first of all the point is it is a permanent mold. So permanent mold is there, then obviously the metal, the casting will solidify inside the cavity. Casting inside cavity or inside die will be the, how it will come out, will be taken out by ejector pins, by using ejector pins. Okay, I'll give you the example. Look at this one. Okay, this is a die, permanent die. You are not going to break this one to take out this casting, isn't it? The casting is here. This is the casting, which is solidified. It is fixed. You cannot take out by your hand also. It is very difficult. So what is done in the die itself, there will be some kind of pin put here. This is the pin, and this pin is pushed. Once this casting is solidified, then this pin will be pushed up. So now this casting will come out easily. Clear? So this is known as ejector pin. This is known as ejector pin. Okay, so this is the function of ejector pin. Okay, so what are the advantages? Let us see about die casting. Oh, die casting are of two types. One is, I told that one is hot chamber and cold chamber die casting. Hot chamber die casting. What is the meaning of hot chamber die casting? What is the meaning of cold chamber die casting? So let us see the diagram first of all. This is hot chamber die casting. So here what is there? You look at this. This is molten metal. Okay, this is molten metal, and molten metal is entering by itself into this cavity. Okay, here some kind of pressure is applied. Okay, so due to that, this molten metal will go and fill up this cavity, and the casting will be completed. Clear? So here what is happening, this whole chamber is inside the molten metal, inside the hot molten metal. Sorry, obviously molten metal will be hot. So inside the molten metal. So that's why this is known as hot chamber die casting. Okay, so like this acts as a, like, you know what, it's a passage, or you can say runner, riser, and all, runner, a sprue, and all, everything. So this is all combined. So the whole gating system is inside the molten metal. Only gate, you can see here, in gate is at this point, clear, outside, but this whole system is inside molten metal, and that's why the whole chamber is heated. Its temperature is very, very high. If whatever molten metal is here, so the chamber temperature will also be that much. So that is known as hot chamber die casting. But in case of cold chamber die casting, we look at this. You see, the metal is poured from outside. This whole thing is not there inside the molten metal. It's outside. It is here, air. This one is air. This is also air. Okay, only molten metal is coming inside. Okay, and after that, with this piston, this molten metal is pushed, and then casting is done. Okay, now why this like this is much easier, isn't it? Because there is no problem of this that like this piston, this cylinder. So there is a chance that if it is surrounded by molten metal, then there is a chance that it also gets melted, isn't it? Or maybe it becomes very, very soft. So if it becomes very, very soft, then obviously it will not function properly. So that's why then why this hot chamber is used. If this is the issue, then why we are going for this hot chamber? So it becomes actually it becomes very fast, because molten metal is there inside, so it becomes very fast. Okay, so for industrial purposes this one is used. Now one thing is very, very clear, that if the temperature of this molten metal is very high, then this metal is going to melt. The chamber completely is going to melt, or it may become softened, but we don't want that. So that's why, which metal will be casted by hot chamber die casting? The metal having low melting point. The metal having low melting point, that metals only can be casted by hot chamber die casting. Clear? So what are those metals? Lead, tin and zinc. Lead, tin and zinc, which is having very low, maybe less than 100 degrees Celsius. Okay, so good for low temperature. It is written 400, but they have a much lesser uh, melting temperature, but obviously pouring will not be done. Pouring temperature will be much higher, that is 200 or 300 maybe. So just remember these metals: lead, tin and zinc. Very low melting point temperature metals are there, and they are casted by hot chamber. Why this is used? I told faster, because it is faster, and that's why this one is used. Okay, and cycle time is very short. Okay, so as we have seen here, hot chamber die cast holding furnace for the liquid metal is integral with the die casting machine. That means the chamber which is holding the molten metal, it's included in the whole, die casting system. But in the cold chamber die casting, the metal is melted separately somewhere else. Here the metal is melted in, okay, and inside that you can say uh, the storage where molten metal is heated and melted. So that there only itself the passage system is there. But in case of cold chamber die casting, metal is melted somewhere else and they are brought, and then it is poured inside the die. Clear? So it takes a long time. Obviously it um, the cycle time is much higher. Okay, so it's now clear why hot chamber machines or hot chamber die casting is used, and in which case cold chamber die casting is used. So as soon as you are going for some other material like high temperature like copper, brass and aluminium, then you cannot go for hot chamber die casting. You have to go for cold chamber die. It means they are to be melted separately, and then they are brought and they are poured inside this cavity. Okay, and then pressed. I told no, it's a die casting, means pressure die casting. So pressure will be applied so that this can enter into all the thin sections. Clear? Okay, so what are the advantage of die casting? Let us see about. Because of the use of movable cores, it is possible to obtain fairly complex casting than is feasible by permanent. I told that complex casting can be done by die casting. Very a small thickness, obviously, because pressure, it is injected at very high pressure. High production rates, I told that because of automation which is possible. And the second thing is hot chamber die casting can be used in case of very low temperature materials. So the cycle time is very less, and due to that the production rate is very high. Because of the metallic dies, very good surface finish is formed in the order of 1 micron. Very nice surface finish you will be getting. 1 micron is 10 to the minus 6 meter. Okay, so you can understand. Closure dimensional tolerance, very nice. That is same thing. Dimensional tolerance or dimensional accuracy is good. The die has a long life. Okay, 3 lakhs of pieces for zinc alloys and 1.5 lakhs of pieces for aluminum alloys. Okay, die casting gives better mechanical properties because of fine grained skin formed during solidification. Okay, this one we will talk about that in forging section. Okay, what is the grain, fine grain, coarse grain and all those things, and due to which the property of material, how it depends on that. So it is economical for large scale production, very economical. Means if you want to set up an industry, then better, and for a casting purpose. Okay, and you are going to do many castings like 3 lakhs and 4 lakhs and 10 lakhs of pieces, then better go for die casting. Better go for die casting. There is no other method which is much economical than this one. Some of the limitations: size of the casting is limited. Why? Because the pressure which will be applied As the size will increase, obviously the pressure required is very high, and obviously that metal may get, because a die is there, no, so it is metallic. So obviously uh, there is a very high heat transfer rate. That means the molten metal can easily solidify in between. So that's why we don't go for very large kind of castings. This is not suitable for all materials because of the limitation on the die material. Okay, so it's not suitable for all types of materials like steels. Steel is having it is casted at very high temperature, but you can see that die casting is not used for steels. The air in the die cavity gets trapped. This is one biggest problem in case of pressure die casting, and that's why another the next casting method was invented. Okay, that the air inside the die cavity gets trapped inside the casting, and therefore a problem occurs with the die casting. What is that problem? So the problem of defect, bubble formation will be happening. The die and machines are very expensive, and economy is possible only when large quantity are produced. So this is the region that air trap is trapped inside the cavity. So that's why we have to take out that air. So that's why the next method was developed. Okay, applications are there: carburetors, crankcases, very small pieces. They are basically developed with the die casting it because it is much faster. Okay, so any material like uh, which is produced in a large quantity. First of all, that is very important. Like you see jeep fasteners. So these are the materials, it is produced in lakhs and lakhs of quantities. So that's why die casting is best for them. So I was telling that air trapped inside, that creates a problem. So now what we are going to do, we are taking out the air, we will remove the air. So that's why the vacuum die casting was developed. So pressure die casting, because of the air entrapped inside, there were defects coming up. So that's why vacuum die casting was developed. In die casting, when the casting is heat treated, blisters will appear on the surface, and obviously because of the air inside, there is a back pressure which you know applied on the molten metal, so which hinders the passage of molten metal inside the cavity. So if very thin section is there where metal has to enter, metal will never enter, because of the pressure inside that cavity. If air is entrapped, how the air will come out? So obviously the metal is not going to go inside. So that's why the whole die is evacuated. Okay, now because of the evacuation, molten metal enters very fast. Okay, and that decreases the filling time. Okay, and obviously because there is no air, so there is no porosity. Oxidation is also avoided because there is no oxygen. So this is basically used for very thin walls, 1 to 12 mm. 10 mm is 1 centimeter, so 1 mm casting also can be done. 2 mm, 3 mm, very thin castings can be done, which is generally not possible in sand casting or other methods. Tight tolerance, fine microstructure. Okay, microstructure we'll talk about that in forging. Okay, so these are the benefits of vacuum die casting. So as you can see here, there are you know the vacuum circuits are there through which the vacuum is created. So here you can see the air is sucked. Okay, so this air is sucked. Here plunger is there, molten metal is put inside, and the molten metal will very fast, it will enter and it will fill the cavity. okay, because there is a pressure applied here, negative pressure is applied here, so metal will be pulled and it will be filled inside the cavity very fast. Okay, so next comes there was a problem with the die casting, the vacuum die casting, there was a problem, and that's why low pressure die casting was developed. Like for casting aluminum and magnesium based alloy, low pressure die casting is used. Since the metal enters the mold slowly with less turbulence compared to die casting, the casting quality is improved, eliminating the defects. So what was happening with the vacuum die casting, that because the speed of metal which was entering was very fast, and due to that turbulence was created. If a speed is more, then there is chances of turbulence, you know how it appears like turbulence. Metal, if it is flowing, then it will be flowing like this. So if a speed is increased, then metal will rotate like this. And due to which what happens that there is a chances that some air will be entrapped, and there are a lot of other problems also happen in case of this one, that is cavities problem. So these are the defect, because of the turbulence this happens. So that's why it has been suggested that for this kind of you know materials, they have low density means it's a light metal, isn't it? So they are light metal, so it was really difficult in case of vacuum die casting to cast these materials, and that's why low pressure die casting was developed. So low pressure die casting was developed for this purpose, aluminum and magnesium based alloys. So close tolerance casting can be made using this process. Okay, so you understood low pressure die casting is little bit pressure is maintained, it's not like completely vacuum is done. Okay, so next. Okay, now we have already covered complete die casting. Now we will enter into centrifugal casting. Okay, this is very important casting. So what is done? Metal is rotated rapidly about its central axis. So what happens? That the metal will go and stick. So pipes, basically आप समझ सकते हो, pipes are made with this method. So big pipes, you see the water or oil which you know which carries the oil. So these pipes are made by centrifugal casting. Okay, metallic pipes. So here what is done? If there is a mold, clear, if the mold is there, just surrounding this is the mold. It's made up of sand. Let us suppose this is made up of sand. Now this is hollow. Now molten metal will be poured inside, and this will be rotated very fast along about its central axis. And what will happen? The metal will stick to the molding sand, or you can say mold, and they will solidify, and then we will get this kind of pipes. Now if we wanted to produce pipes in case of die casting, in case of sand casting, if we wanted this hollow area, then what we had to do? We had to put core. We had to put core inside. Are you getting or not? This core was put. Then only, and this was core made up of core sand. And then only we were getting this cavity. But in this case, there is no need of core. Clear? So there are three types of centrifugal casting. Let us see one by one. One is true centrifugal, semi-centrifugal, and centrifuging casting. So true centrifugal means that any casting or any pipes or any hollow tubes which is axis symmetric. What is the axis symmetric? This is the axis, okay, and the casting is axis symmetric. That means the radius here and the radius here both are same. Okay, this is axis symmetric. So this kind of casting is, if we are doing, then is known as true centrifugal casting. So what is done? I told similar thing, that this is the mold, thickness is this much. This mold is basically made like this, something like that. Okay, this is the cavity. Okay, now inside this molten metal is put. Okay, here you see, this is a pouring basin, molten metal is poured inside, and what is happening, this molten metal is put inside, and now because this is rotated at some certain speed, so this molten metal will stick around this surface and then get solidified. So are you getting? Then you will get a pipe. Now this pipe may have different kinds of shapes also, like this kind of shape. This is a pipe. This is a pipe. So this also can be casted. So any kind which is axis symmetric. Axis symmetric means this distance and this distance from the central line should be same. So any kind of shape which is having this kind of so that can be casted by true centrifugal casting. Okay. So very long pipes are normally cast with horizontal axis. So this casting can be done in horizontal axis also and vertical axis also, but long pipes are there, heavy pipes are there, that has to be casted in horizontal axis. But if short pieces are made, that is better to cast in vertical axis. Horizontal axis, why it is preferred, because if you are doing vertical axis casting, this is the if molten metal is poured, so there is a chance that molten metal, the casting which will be done, the thickness will vary of the pipe. So in the bottom the thickness will be more because metal has got accumulated at the bottom, so thickness will be more. So the pipe which is coming, basically it will look like this. From inside it will look like this, but outer it is same. You see, outer diameter is same, but inside diameter it is reducing like this. So that is not desired. So for long pipes it is not desired that we do vertical axis casting. So that's why it is done horizontally. Next we will talk about semi-centrifugal, where this semi-centrifugal casting is used. Okay, so advantages are very some of the advantages are, see, better mechanical properties. This is the benefit of centrifugal casting. So when we are doing centrifugal casting, okay, what is happening, that we know due to the centrifugal force, okay, the particle which is having high density, that will be thrown far, and any material which is having less density, that will be near the center. Are you getting or not? So these particles are basically, which is having low density, they are slag, and this black one is metal. Okay, so slag is separated. So if slag is separated, or any kind of oxide or impurities that is separated, then obviously you will be getting better mechanical property. Second thing is that because of the pressure of centrifugal force, or you can say centrifugal force, any kind of porosity is there, that will be eliminated. Clear? So this is the advantage. And second is because also some mechanical properties, because of directional solidification. Which metal will solidify first, the metal which is on the surface or which is near the center. obviously on the surface the metal which is thrown far, that will that will cool down fast and it will get solidified first, clear, and then the solidification will gradually go towards center. Are you getting? So let's suppose this is the casting, this is the casting having thickness like this one. So first this peripheral metal will surface will solidify, then it will come down, okay, and like that it will proceed towards the center. So this is known as directional solidification, and this directional solidification is very very important to improve the mechanical property. I told that there is no need of cores for making the hollow casting, isn't it? And no need of gates and runners and all those things are not required, because the metal when it is rotated, you know, and there is a like pipe through which the molten metal is poured inside. So this pipe will run from here to there, okay, like this. It's running and it will be pouring metal at this place, and then it will be coming back. So there is no need of gates and runners and all those things, and so the extra metal which is wasted inside the gate and runner and all, which is removed after, you know, casting, so that is not removed here. So obviously there is no need of removing all those things, and that's why the casting is like 100%, there is no wastage of metal. Okay, so next we will talk about centrifuging, semi-centrifugal. Okay, limitations are simple, the same, because you know axis symmetrical objects only can be casted in this case. Okay, you cannot do casting which is having some kind of, you know, different kind of shapes, like this one. This is a pipe. Okay, you cannot cast it because it is not symmetrical, clear. And second thing, the equipment is expensive, okay, because it is to be rotated. So any rotational, wherever you find rotational movement, then there is a problem that the equipments will be expensive. Okay, so okay, so next we will talk about semi-centrifugal casting. So any casting which is axis symmetrical, obviously it is axis symmetrical, okay, but it is more complicated, okay, then in that case we go for semi-centrifugal casting. Okay, see here, this is the central core, okay, and the metal, actually this is rotated in this way, okay. So yeah, this is the mold, sand mold, okay, and you can see this is all sand and the cavity is here, this black portion is cavity. So molten metal will be poured inside. Let's suppose this is poured here, then what will happen, it will go to the farthest places like this one, okay. So any complicated kind of casting can be done by semi-centrifugal casting. So here it is written, the molds made up of you know, sand or metal are rotated about a vertical axis, and metal enters the mold through the central pouring basin. Oh, here is the central pouring basin. Through this, this one is, I told this one, yeah, correct. So through this molten metal is poured inside and it goes to different places. So if more complicated kind of casting is to be done, and still it is sent, you know, through this center, through this axis, basically this is the central axis, through this you see the distances are same, okay. So all it is axis symmetric, isn't it? But it is not completely centrifugal casting. So here the speed is not as high as true centrifugal casting. So let us move to next one, that is centrifuging casting. Now in this case it is similar to semi-centrifugal casting, because the metal will be poured through this passage. Okay, now what is done, you see, any kind of shape you can cast through this one, any kind of shape, but it has to be very small shapes. Like let's suppose you want to cast these kind of rings. 4 rings are there, 6 rings are there, or maybe 10 also. So they are all there is a cavity made on a plate. This is a big plate. On that the cavities are made. Okay, and all are connected through runners. These are the runners. Okay, and here the if this disc is rotated, so any metal present here, what will happen to this metal? It will go towards this because of centrifugal forces. It will go there and it will fill this cavities, and we will get the casting. Now this is placed like this one. So this is the central portion, and molten metal will go this side, this side. Okay, so in this way the molten metal come down and it will go there. So this is similar to semi-centrifugal, but in this case any kind of shapes, small shapes can be casted, many small jobs of any shape. So in this way we have completed centrifugal casting. So now let us go for continuous casting. Continuous casting. So continuous casting is basically used when you need some kind of long bars, like square bars are required, like this kind of shape, very long, 20 meters or 40 meters, something like this. Okay, so this kind of bars are required. So you know that these bars are produced by forging operation, rolling operation we say, not forging, rolling. So 2 rollers will be there. Okay, and this is the metal. Okay, so it is, let's suppose this is in a cylindrical shape and we want this kind of shape. So the die will be made, actually the roller will be made in that shape, and this is rotated, this roller is rotated like this. So what will happen, this metal will come out through this one and having that shape. Whatever shape this roller will have, the same shape it will come out. Are you getting? So this is these are the rollers. Okay, and this is metal. Okay, so this is rolling operation through which these castings are this kind of shape we get, and long uh, very long pieces like 20 meter or 40 meter or 10 meter, something like that. Continuously you can do rolling operation and you can get the objects. But it was not required in many cases. It was not required to do the rolling operation because it requires lot of pressure. So to rotate these rollers it requires a lot of force, a lot of power is required, isn't it? So obviously power consumption will be more. So it was thought that why not we prepare this kind of casting itself. Molten metal has to will be casted in this shape only itself. See, its shape is how much, the size of this one. See, length is 20 meter, but the size is maybe 20 mm by 20 mm, so like that. So if this kind of shape is to be made, then it is not possible to do this kind of cavity, make this kind of cavity of 20-meter long and then pour the molten metal and then do the casting. It is not possible in this way. So that's why this continuous casting was invented. Now look at this, look at the whole system. So here is that, here the molten metal is filled inside this chamber. This is the mold cavity. It's basically made up of copper. This is made up of copper. Now this is completely filled and it is found that okay, sufficient height is reached. then these are the rollers. Okay, so here the molten metal, this will solidify. Now this will come out, and because these rollers cannot catch, or you can say cannot catch the molten metal. How can you catch molten metal? It is not possible. So this, how it will be pulled. So this solidified molten metal here, that comes here, and now as soon as it comes in between these two rollers which is rotating, so now this pulling force is acting on the whole metal, and this solidified metal will go like this, pulled down 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 like that, and it's made like this continuously it is made. And here you have cutting mechanism. Whatever desired length you want, that by that you can cut it. Now here the shape change is happening. If you want uh, any round shape, any cylindrical rod, then you can get that. Or if you want any kind of square rod, something like that, having a square cross section or rectangular cross section, or kind of any kind of shape you will be getting. Clear? So these kind of shapes you can easily get by these rollers. So this is continuous casting. So that is the benefit, that the power consumption to run that roller is now eliminated. Clear? Okay, so I am going too much fast because of the time we don't have. We are already very late. Now I told that continuous casting and squeeze casting, actually they are using the forging and casting method. So here all forging is used, you see. So if we want this kind of shape, clear, so what is done, molten metal is poured inside this, and this is a punch. Okay, and this punch will be inserted, so molten metal will rise and it will completely fill the surface. But because of the punch, the central part is hollow. So if that kind of shape is required, then by this punching operation, by squeezing the metal, we are going to get the casting. What are the benefits of this? There are lots of benefits. You see, very low gas entrapment, the gases will not be entrapped. Okay, and there will be low shrinkage cavity. And also the cost of the die is very less. As we can see, there is no such very big equipments are used. Okay, and high quality surface is achieved. So basically the point is that mechanical property of this casting is very nice because of the defects which is not present. Shrinkage, this is the main point, the shrinkage cavity is not present, and low gas entrapment and shrinkage. Due to that, the casting which we get has very good quality. So what are the materials which are casted through this? Aluminum, magnesium, copper. Basically these are the light metals. Light metal casting is very difficult. Steel, there is no problem, you can do sand casting. But the light metals like aluminum, magnesium, copper, these are light metals, and they have a lot of difficulty while casting. Even welding also, we will study in welding that you will find that these light metals are very difficult to weld. And especially this aluminum has a lot of problem. Okay, so now we will move towards slush casting. This is the last one. So I told that cell mold casting and slush casting both are categorized in a one category. So I told cell mold casting. Cell mold casting means what? The mold is made as a cell, the mold cavity. Okay, so it is made by a mold. and this mold is in the form of cell. Cell means the thickness, wall thickness will be how much? Very, very less. Wall thickness is lesser than volume or surface area. Okay, very, very less, much lesser as compared to the volume of the space which is inside. So that's why this is known as cell. So here the mold is cell, means cell mold is used. But in case of slush casting, the casting thickness is less. Are you getting or not? The thickness of the casting is less. Now here how it is done. So let us see the picture and then we will easily understand that. You see here, like this is the cavity. Okay, this is the cavity made. Okay, now you can make it, it may be of metal or something else also. There is no problem here, but cavity is made. Now this cavity is having, it's like a mango. Okay, now just take the shape of a mango. Just imagine that this is the shape of a mango. Okay, now molten metal is poured inside, completely filled, and after that, that molten metal is again inverted and taken out. So what will happen? So very thin layer of molten metal will stick around. Okay, now this thin layer of molten metal is stuck. So that will be just like mangoes peel. Okay, green peel. So that is that much thickness will be left. Okay, and whole molten metal will come out. So this thickness that is required basically. So this is known as slush casting. So this is the final casting, which is just like any kind of the idol, any metallic idol which is made up of metal. So you will see that from inside it is hollow. From inside it will be hollow. But so how it is made? That is made by this slush casting only. What is done? What is done? So there will be a cavity having nose and eyes and all everything, the whole shape of that idol, and then molten metal will be poured inside, and after that that molten metal is taken out. Then there is a thin layer of metal will be formed around it, and it will form the nose, eyes and all everything. Okay, so this is how the slush casting is done. So now you understood what is the difference between cell mold casting and slush casting. Cell mold casting, the molding, the mold itself is very, very thin, but here the casting is very, very thin. Now how it is taken out from this one, from this mold? So obviously this is not made up of metal. You cannot make it as of metal. Yeah, you can make it of metal, but there should be pieces. Okay, like it has to be partition and it is joined. So after that you just take it out and open that whole mold and take it out. And if it is made up of sand, then that's also good. Made up of sand, then sand will be broken and this can be taken out. Clear? Okay. So used to produce hollow casting without the use of a core. Tools used are relatively, actually this is used for even producing ornaments, even ornaments having various good shapes. So what is done? Let's suppose this is the shape of ornament, let's suppose. Okay, and now what is done? The molten metal is filled here. Gold is filled completely, and once gold is filled, after that this gold will be taken out. And what will happen? A very, very thin layer of gold will be formed here. Locket, lockets, or these are formed lockets and all everything which we wear. So these are all made by slush casting. So like this, it is, this thin layer is formed, Now this thin layer is the our casting. Okay, this is a locket uh, having some kind of shape. It uses a permanent mold without any core. See here it is written permanent mold. That means obviously this is going to be uh, metal. Okay, the casting starts solidifying from the mold wall towards the inside the casting. Means from the wall it is going inside the casting. Okay, so from here the solidification will start and it will proceed in this way. So cell wall thickness depends on how much time you are keeping the metal inside. Are you getting? If you are putting the metal for a longer time, what will happen? The whole metal will solidify. Then what is the use? So that's why it is very important. You have to know that how much time I have to keep, so that this much thickness, whatever required thickness is there, that is achieved. Once that is achieved, just take out the complete molten metal. Clear? So this is known as slush casting. So we have almost completed everything, and here are some of the questions which can be asked. These are the questions in this way that will be asked. So these are all the subjective questions, like compare precision investment casting and cell molding from the standpoint of process, how the difference in the process, the difference in the applications. So this is how the question will be asked. Although sand casting is the most widely used process, judging from the tonnage of casting produced, there are instances where one would choose die casting in preference to sand casting. Discuss the statement. I told why die casting is preferred over sand casting. Similarly, give example of typical products of following processes. Die casting. What are the typical example of die casting? Centrifugal casting, like pipes. Permanent mold casting. Okay. Cell mold casting. What are the, like piston cylinder and all. Specify the advantage of precision investment casting over other casting methods. Precision investment casting. This is the main point. Precision. Okay. So this only gives you the idea. Describe the composition of the mold material in cell mold casting. Cell molding. What is the mold material? Mold material is dry sand and resin. Which resin? Thermosetting resin, phenyl formaldehyde resin. What is the main difference in the quality between a sand casting and casting in a metal mold? Sand casting and casting in a metal mold. First of all, sand casting surface finish will be very poor, but in case of metal, it will be very good surface finish. Dimensional accuracy will be very nice, and uh, the mechanical property will be good. That I will talk in the forging. Why is most die casting not made up of high strength materials? Die castings are not made up of made out of high strength materials. Is it is it possible to obtain a sound casting of a solid bar by centrifugal casting? No. Sound casting of a solid bar by centrifugal casting is not possible, because solid is not for centrifugal casting. Solid objects cannot be made. A rod we have to make. It is not possible, So that is not possible. State the difference between centrifuging and true centrifugal casting. We have told in centrifuging casting any kind of casting can be done, but in true centrifugal only axis symmetrical casting can be done. Here only small jobs are done, many small jobs at a time, but here only one casting, bigger one can be done. Many other differences are there. What are the typical one very important difference in the centrifugal casting, as we have told, like this is the disc. In that disc many small castings hollows are there. Okay, now this disc will be rotated, so due to the rotation the metal will flow in this direction. Clear? And what about the slags? Slag will also move in this direction. So you see the more metal is like little bigger way. I'm going to make, like this is the cavity. Okay, this is the center. So metal and slag both will proceed. So metal will go where? at the boundary. This is metal, and the the slag, it will form here. This is slag and this is metal. So here metal will be more, here slag will be more. Now you can understand what are the problems which a centrifuging casting is going to face. So our whole casting will be spoiled. So that's why it's very important. But that is not a problem in centrifugal casting, because I told slag is completely separated. But here, half is metal and half is slag. That is not good. So these are some of the questions you can practice by yourself and see that if you are able to solve this or not. Okay, thank you very much. We have completed our special casting methods.